nous allons passer au 9e candidat. Il s'agit de Loris di Natale. Donc en italien, non?
Français. Non,
en
plutôt français.
Non, c'est vrai?
Oui.
Ah, moi j'ai noté anglais.
Ah oui, non, la présentation est en anglais.
Ah, d'accord.
En italien, j'arrive pas à faire le small talk.
OK. Physics-inspired deep learning for building, modeling and control. Ça, c'est le titre, travaillé au Automatic Control Laboratory 3 with Professor Colin Neil Jones. It's your turn. Enjoy.
Thank you. All right. What if I told you that I could make you save 30% on your building energy consumption? For that, I'm going to deploy this neural network and let it control your heating system. There is only one tiny catch in that story. I don't really know how that guy works. The issue is that a neural network is an artificial intelligence that is trying to replicate our human brains. It will take some data as input and then feed it through a network of artificial neurons. Each neuron will aggregate the information it receives, process it, and then transfer it to the next neuron. And at the end of the chain, you get the desired output. In our case, this network will be looking at the temperature of the building, for example, the weather conditions, and so on, and then it will decide and output whether we should heat the building right now or not. Now, the magic about neural networks, really, is that we actually know how to train these beasts. So we know how to tweak the connections and the neurons towards a given objective. In our case, we could train this guy to minimize the energy consumption of a building, of course, making sure you're not freezing inside. And at the end of the training, it is actually able to save a lot of energy. Now, the issue is that to get to this amazing performance, the connections inside get so complex that it becomes essentially impossible for any human to really understand what's happening inside. Now, in practice, in a lot of cases, you might not care how something works, as long as it works, right? But I can tell you that it will fail at some point. The issue is that when I tell you that we know how to train neural networks, that is true. But what I did not mention is that they only do exactly what we tell them to do. If we now take this network, deploy it in your building, and then get, say, an extremely cold weather, something it has not seen during its training, then we have essentially no idea how it will react. This means you could be just freezing inside because for some reason it decides to stop heating your building even though it's minus 20 degrees outside. To solve these kind of issues, in my PhD, we are looking at ways to alter the structure of the network, to encode some properties in them. You can picture these modifications as replacing a few of the classical blue connections and neurons with our own orange ones. Now, importantly, we only want to intervene in a tiny part of the network so that we can still rely on the many blue connections to solve very hard problems. But these few modifications allow us to guarantee that the network will follow some simple ground rules that we set. For example, make sure it will always turn on the heating whenever the temperature drops, whatever the weather is doing. At the end of the day, I still don't really know what that guy is doing. But at least now, I can tell you that it is not doing something completely stupid. So you can actually trust it to be able to save up to 30% of energy consumption, while also making sure that you will never freeze to death on your couch on a cold winter night. Thank you. Merci beaucoup.